Welcome to the Science Salon podcast. I'm your host, Michael Shermer. We post these conversations on average once a week as part of the larger mission of the Skeptic Society and Skeptic Magazine, a 501c3 nonprofit educational organization devoted to promoting science and reason. We depend upon and appreciate your support, so if you find this podcast valuable, along with our magazine and other projects we work on, please support us at skeptic.com/donate. That's skeptic.com/donate. There you can support our work through a one-time or recurring donations via PayPal or monthly donations via Patreon. You can make a direct one-time donation via Shop Skeptic. Just click the donate button at the top of the skeptic.com webpage. Or you can just send us a check in the mail or even call us on the phone. The Science Salon podcast grew out of our original Caltech Distinguished Science Lecture Series, which then morphed into our Science Salon live events. And now, thanks to technology, we can produce weekly dialogues with leading scientists and scholars on a variety of topics. My guest today is Sir Martin Rees. Dr. Rees is a leading astrophysicist as well as a senior figure in UK science and a public intellectual in England and America. He has conducted influential theoretical work on subjects as diverse as black hole formation and extragalactic radio sources. And in the 1960s, his research provided key evidence to contradict the steady-state theory of the evolution of the universe. Martin was also one of the first to predict the uneven distribution of matter in the universe and proposed observational tests to determine the clustering of stars and galaxies. Much of his most valuable research has focused on the end of the so-called cosmic dark ages, a period shortly after the Big Bang when the universe was as yet without light sources. As Astronomer Royal and a past president of the Royal Society, Dr. Rees is a prominent scientific spokesperson and the author of 7 books of popular science. After receiving a knighthood in 1992 for his services to science, he was elevated to the title of Baron Rees of Ludlow in 2005. His books include Before the Beginning, Our Universe and Others, Just 6 Numbers, The Deep Forces That Shape the Universe, Our Cosmic Habitat, Our Final Hour, A Scientist's Warning, How Terror, Error, and Environmental Disaster Threaten Humankind's Future in This Century, on Earth and Beyond, From Here to Infinity, Scientific Horizons, and his new book that we discussed today on the podcast, On the Future, Prospects for Humanity, just published in October from Princeton University Press. You can order it on the webpage that we are hosting this podcast on. His next book that he's working on now, which we discussed toward the end of the podcast, is What We Still Don't Know, which turns out to be a lot, not surprisingly. So with that, I give you Sir Martin Rees. But before we get into your new book, maybe give us a little biographical background. How does one start off with a young interest in astronomy and science and end up as the Astronomer Royal?
Right. Well, I was brought up in the country, in Shropshire, west of England, and I was interested in nature and good at numbers, but I wasn't really especially keen on astronomy. But in the English school system, you have to specialise when you're 16 in a particular area. And I was bad at languages, so I went in for science. And I turned out to be good at math. And when I went to university to Cambridge, I studied math. But I realized that was not what I wanted to do. I wasn't a guy with a mindset of most mathematicians. So I tried to think of something to apply the math to, which was more sort of synthetic and synoptic. I thought quite seriously of being an economist. And so my friends became economists.
Wow.
So, yeah. But through a chain of accidents, I ended up being a research student working towards a PhD in a group in Cambridge. And I was lucky in 2 respects. The first was that the person in charge was a guy called Dennis Sharma, was very charismatic, and we had a very strong group of students working together. And also, this was the mid-1960s, and this was the time when we had the first evidence of the Big Bang, first indication neutron stars and black holes. And it's always good to go into a subject where things are opening up, because then the old guys don't have much of an advantage, and it's easy to make an impact young.
Career opportunities, yes. Yep. Well, given the current news about Brexit, maybe your skills as an economist might have been helpful at this point, but you didn't know that back in the 60s.
No, and that's far too difficult for anyone.
Yeah, that's right. Now, that's a really hard science.
Yes.
So at that time, the Big Bang theory and the steady state theory were in competition for the best explanation for the data. And you kind of went through that revolution where the Big Bang theory won out. How did that unfold? Was it just sort of month by month or year by year?
Well, the first indications that the steady state theory wasn't correct came from actually someone else in Cambridge called Martin Rees, a radio astronomer, and he realized that the sources that he was detecting with the radio telescope were a long way away. He couldn't detect the distance because he didn't have a redshift, because he couldn't be seen optically, but he thought it was a long way away. And he noticed that the relative numbers of faint and bright ones were surprisingly high, higher than it would be if they were uniformly distributed. And he explained this by saying that these kinds of radio sources, which weren't understood at all at that time, were more common in the past than they are now. And therefore we see more distances that are large than distances are small. And this was actually a good argument. And this was the first evidence that the steady state theory wasn't correct, that the universe had changed with time. But of course, the big thing was in 1965 when we had the discovery of the cosmic microwave background. And that really quite quickly convinced most people that that radiation was left over from the hot, dense beginning of the universe. Fred Hoyle, of course, who I got to know in his later years, he never fully accepted the steady state, was dead, and he compromised with what I would call a steady bang theory, a compromise. He never really took on board fully the Big Bang theory, which is sad.
Yeah, I wonder if that's a product of the Planck problem, where Max Planck said, new ideas develop, one funeral at a time.
Yeah, well, I'm afraid that's true. And also, in my book, I discuss the various ways in which scientists grow old. And one way is by getting stuck with new ideas. But in Fred's case, he was still intellectually active, but he went the other route where you try to invade new fields where you've got no expertise. And he went into biology and tried to say that Darwin was wrong, etc., and had lots of ideas that didn't enhance his reputation. But sadly, he never fully took on board the Big Bang, although by coincidence, he was a good friend of Willie Fowler, and he and Fowler together with Bob Waggoner wrote some classic papers on the Big Bang. They were the first people to actually work out that in the early stages of the Big Bang, the first few minutes, nuclear reactions would make helium, deuterium, and hydrogen in proportions which were observed. And this was the second great pillar in favor of the Big Bang theory. Right. It did not gave the radiation, but gave the reason why there was so much helium in the universe.
Right. So in your book, you talk about when you're sitting next to somebody on a plane and you don't want to talk to them, you tell them you're a mathematician. When you do, you tell them you're an astronomer or a cosmologist. You must get this question a lot. Where did the bang from, or from what? Or why is there something rather than nothing and all that? How do you answer those big questions?
Well, I say we don't know the answer. But what I say is that we've made huge progress in the last 50 years because, as we've just said, in the 1960s, we didn't know if there was a Big Bang at all, whereas now we can trace back with fair confidence and a few percent accuracy right back to a nanosecond, a tiny, tiny fraction of a second, and say what happened then. And we've got fairly good evidence. And back to a nanosecond, I'd say our evidence is as good as anything you learn from a geologist about the history of the Earth. And that's great progress. Now, of course, all progress brings into sharper focus new mysteries that we couldn't even have posed back then. And, of course, among them is what happened in that first nanosecond.
Right.
And what banged and how did it bang. And the stumbling block there is that the physical conditions in the first nanosecond were far more extreme than we can actually create in the biggest accelerator even. So we have a foothold in experiments when we are trying to model the first nanosecond. And that's why we don't yet have an answer to these big questions. But they are big questions because we'd like to know, why is the universe expanding the way it is? Was our Big Bang the only one? Etc.
So if time begins with the Big Bang, it's a nonsensical question to ask what was there before the Big Bang, in a way.
Well, of course, I think most people would say that when we get back very near the beginning, we have to jettison even more of our everyday concepts. We're not used to the idea that in the micro world, quantum effects are rather spooky and counterintuitive. But when we get back to the tiny, tiny first instance, most people suspect that the whole idea of 3 dimensions of space and 1 dimension of time ticking away have to be generalized in some way. And we can't think of the dimension of time being separate. And one idea, which is very popular, of course, is string theory, which is that extra dimensions come into play. So the short answer is that we don't know. The longer answer is that lots of people have ideas which would make that question slightly more meaningful.
The answer that we live in a multiverse and there's other universes and maybe some of them banged, there was some collapsing black hole in another universe that gave birth to ours, all that. Theists often say, well, that's just a bunch of hand waving. How is that different from us saying God did it?
Well, first of all, I'm saying we are not dogmatic about this. We have no idea. But what I'm trying to say is in the next 50 years, we may answer some of those questions, just as in the last 50 years, we've gone from knowing nothing about a Big Bang to knowing quite a lot about it after the first nanosecond. So I'm hoping that perhaps, although I won't be around 50 years from now, we will understand some unified theory that links together gravity and the quantum principle and tells us why our Big Bang is expanding the way it is and whether there are others. So it's a scientific question, but at the moment we can't answer it. It's a speculation.
So it's okay to just say, I don't know, and leave it at that for now.
Well, I mean, it's good that people are trying to address it.
Yeah, that's what graduate students are for.
yeah, but I think another point I'd make is that when we talk about the big questions, it's really only cranks who tackle them head on. You've got to advance piecemeal and realize that we can't solve this big problem, just like Nixon's war on cancer failed, because he said we can solve cancer in one go. But of course, all we could do at that stage was understand the biology of cells better. And likewise, we've got to understand extreme physics in the subnuclear world and understand some kind of link between quantum theory and Einstein's theory before we can make progress. But nonetheless, I see no reason why there shouldn't be progress in the next 50 years to answer those questions. But of course, there may not be. One point I mentioned in my book is that there are some questions which may simply be beyond the capacity of our brains to take on board. I suspect that they're not going to be in physics. They may be more likely to be in brain science. But I think we've got to be open-minded about that. But we mustn't give up because we're still right at the beginning of these studies.
Yeah, you did mention in your book the sort of limits of science. Do you ever call yourself a Mysterian in any of these big questions? It's not possible for us to know, our brains aren't big enough or whatever.
Well, I mean, I think we're nowhere near these boundaries, but it may turn out that we can't develop beyond a certain point. And of course, we can perhaps with the aid of AI, but that's not quite the same as having a full instant comprehension of what's going on. We actually understand in a deep way some scientific concepts, but we may never be able to understand in a deep way these more complicated things, even though we may have computers which can do the mathematics and tell us whether they're right or not. So I think we are going to run up against a problem where we are going to need computers to do the calculation. For instance, string theory, the problem there is that no one has yet been able to calculate, starting with a complicated 10-dimensional mathematics and geometry of string theory, anything that we can actually measure in our ordinary low-energy world. It could be that is a problem which is just too complicated without machine assistance, just like, of course, in a simpler way, the famous four-color theorem in mathematics needed a computer. But this, in a deeper sense, is going to need computing power and maybe AI. So I think we may learn about the validity of string theory by AI added to the human brain. But, of course, there are other problems we're probably not aware of. And just as a monkey isn't aware of quantum theory, there may be
Right.
deep aspects of reality.
Yeah, you mentioned cranks. You're a pretty prominent public intellectual. You must get a lot of these letters from people saying, I've worked out the explanation for the universe or whatever. Einstein was wrong and Feynman was wrong, and if you'll help me work out the math, I'll share the Nobel Prize with you.
Yeah, I get people like that. They say they just need a bit of help with the math, and I say I've got my own problems to solve. But the other thing that gets the biggest correspondence, of course, the most letters, is about aliens.
Oh.
Since I'm involved in SETI searches and things like that,
right.
you get letters from people who think they know the answer. They think that they've been
in contact,
or abducted by them, as you know. And I say two things to these people. I write back saying, do you really think that if these aliens had made a huge effort to traverse interstellar space, would they just make a corn circle, meet
Right.
one or two cranks and go away again? It seems
Right.
unlikely. The second thing I say is they should write to each other and not to me. And I'm sure they'll communicate very well with each other.
That's right.
As you say, this is a subject that attracts a lot of that attention. But of course, the upside of that is that astronomy is a subject which doesn't have wide public interest. And this is a good thing because
Right.
not directly promoting human welfare in a practical sense, but we are stimulating intellectual interests in a very wide public. And I think this is very important. And I myself would find my work less satisfying if I could only talk to a few fellow specialists about it. I think it's a plus that one can actually convey the essence of the ideas, if not the technical details, to a wide audience.
To the question, when are we going to make contact with aliens? I mean, you either do or you don't. That's like, when are you going to get pregnant? Well, it's not a gradual process. And yet maybe you could make some predictions based on the algorithmic growth of computing technology and radio telescopes that are being focused on the search, and maybe that's accelerating, so we can say something like in the next half century, we have a 50% chance of making contact or something like that.
But I think the search is deepening, and I favour the search, and I chair an advisory group for Yuri Milner's program called Breakthrough Listen,
Right.
which is putting new instruments on radio telescopes and looking in other ways for something which is manifestly artificial. I think it is worthwhile, although I'm not holding my breath for success. But I think there will be progress in two things in the next 20 years. First, I think we'll come to understand better the origin of life on Earth, because even though we understand that we're the outcome of Darwinian evolution spread over nearly 4 billion years, nobody understands the actual origin of life, the transition from complex chemistry to the first replicating, metabolizing object we call alive. We don't know that. I'm optimistic that this will be understood in the next 10 or 20 years, because it's a topic that's been put in the too difficult box, as it were, without serious people working much on it. Whereas now that's changed. There's some very serious people who are working on that problem. And of course, if they solve it, it'll tell us two things. It'll say, is it something which is probable given the right environment, or is it a rare fluke? And also it'll tell us whether there's something really special about the DNA, RNA basis of life, or could it form in other ways with other chemical bases. So I think that will happen. And of course, the other thing is that we are now able to explore possible sites of life elsewhere, obviously on Mars, maybe under the ice on Enceladus, the moon of Saturn, but also on some of the exoplanets around other stars. We know there are 1 billion Earth-like planets orbiting stars in our galaxy, and the nearest ones have been detected indirectly by looking at their effect on the parent star. But within 10 or 20 years, we have telescopes able to analyze the light from these Earth-like planets around other stars to get some idea of whether they've got a biosphere.
You mean, so if the atmosphere of one of these exoplanets had methane in it or oxygen, this would be a sign?
Yes, or some kind of equilibrium, then that would indicate some sort of biosphere. We might see lots of things that are green or something like that. So the idea of detecting evidence for some kind of life elsewhere is something which may be transformed to an experimental or observational science in the next 20 years. Right. And of course, that will tell us whether life is widespread in the universe. But of course, intelligent life is another question, because even if simple life is common, intelligent life might be rare. But I think, to go back to what you said a moment ago, I think if we detect something which is manifestly artificial, it won't be a sort of civilization like us. It's far more likely to be something electronic,
right,
which may be created by some civilization like us, which became extinct many millions of years ago.
I haven't seen anything on Tabby's star, that star that its light is being dimmed significantly. I forget, it's like 20 or 30%. Can't just be exoplanets blocking the light. Could it be something like a Dyson sphere or gigantic solar panels, or is it more likely to just be debris?
Well, I think the exciting possibility is it's something like that. But of course, extraordinary claims require extraordinary evidence. The
right.
probability of that is very low. There are a number of explanations. One is that it may be caused by some sort of intervening dense interstellar cloud, not attached to the star at all. That's one possibility. Jason Wright at Penn State University has advocated that, but we don't know. But I think one shouldn't jump to the conclusion that something has an exciting explanation. It's probably got some mundane explanation, although nonetheless it is a puzzling phenomenon at the moment.
Remember doing a radio show in Los Angeles here, afternoon talk radio, and the hosts, John and Jillian, they had on George Noory from Coast to Coast AM, which is one of these kind of conspiracy paranormal type radio shows that
I was on that a month ago. Yes.
Oh, you were on that. Yes, of course they would have you. Yes, so you know the audience there, and this is when this was a couple of years ago when that Tabby Star story broke, and immediately the hosts are like, well, what are the aliens like? To George Norton, like he knows, like it's like, wait, no, it's 1,400 light years. Yeah, 1,400 light years away. Even if there were aliens, but no one's talking about aliens. We're just talking about an anomaly. But it shows you how quick the mind goes, to the average listener. Like, it's an exciting idea.
But we should be on the lookout for its anomalies, obviously, because we don't really know what to expect. We should look for things like Tabby's star, any kind of anomalous emission in any wave band, and also in our solar system, any asteroid that looks especially shiny or something like that could be something which is artificial. We ought to keep our eyes open.
There was a story last month about that elongated flat
that's right.
asteroid that some speculated could be an artificial satellite.
Yes, but there again, there were far more plausible explanations for that.
So what's your quick answer to the Fermi paradox of where everybody is? Where is everybody?
Well, I have no answer. I mean, a colleague of mine wrote a book with 50 answers,
right.
Fermi Paradox, and then he wrote a second edition with 75.
75. Okay, there's that many now.
So there are lots of, your response to that should be that one good argument would be enough, but you've got 75 weak arguments. I think the point is we don't know what the aliens would do, what their motives would be if they did exist. They may be contemplatives. There's no particular reason why they would want to be expansionist, etc., and come here. And I think, incidentally, one very serious fallacy that people adopt in the general context of AI is to assume that they be like us, because if we think of how we evolved by Darwinian selection, two qualities were important. One was intelligence, but the second was aggression.
Oh, right.
Whereas if we make some AI, then we want to design it. It'll be a sort of secular intelligent design, and we want it to have intelligence. But of course, there's no particular reason why it would be aggressive. I mean, it may perhaps mindlessly follow some goal if we give it a foolish goal, but there's no particular reason why it should have that quality, because it's not engaged in Darwinian selection.
Right.
So I think there are lots of reasons why, even if these entities exist, we wouldn't have detected them. But of course, they could be so different from us, we wouldn't recognize them.
Yeah. Did you buy Hawking's argument that we should not make contact because they might be evil and colonizing like we were?
No, I can't take that seriously. In fact, it was your colleague, Mr. Brin, who was the first person to emphasize this. But I find it hard to take it seriously, because if they're out there, then they're probably watching this planet for a million years, and they know we're here already. So right. I took to I don't really take that argument at all seriously.
Yeah, he emphasizes a particular period of human history when colonialism was rampant in the Western world anyway. But Pinker makes an interesting argument. I think it's in the Enlightenment Now, his new book, that there is a species of highly intelligent beings that are not aggressive and warlike. They're called women.
Right. Yes.
So there's no reason why aliens are going to be like young men in their 20s.
Yeah. No, I agree, and they may be more philosophical, more contemplative than us.
Right. Yep. Yep. So in the SETI search and in the Drake equation, there's that final element of L, the length of a civilization. Maybe the aliens destroy themselves. So this gets us into your last two books, Our Final Hour, and then on the Future.
Can I comment on the Drake equation?
Oh,
because
yeah.
I think we need to rethink that, because if we think of what's happened on Earth in the last 4 billion years, or what may happen, then we've had 4 billion years of Darwinian selection. Then we've had a few millennia of technology. But if we look ahead, then within another millennium, the machines may have taken over, and they may spread beyond the Earth. If they do spread beyond the Earth, they will go on for another few billion years. So the lifetime of a civilization like ours may indeed be quite short, but it may end not by being wiped out, but by transforming itself or modifying its intelligence into some form that can be almost immortal. So I think I would be more optimistic if I look at the Drake equation in that new light.
So we need a new term in the equation, AIL.
Yeah, that's right, because I think if we detect AI, it won't be a sort of civilization in our sense.
Right.
It's far more likely to be some single unified mind, maybe in interstellar space.
Yeah. Wow. But of course, we have to get there, and you're concerned as not just as a scientist, but as a citizen that we're doing things now that may not enable that to happen.
Yes, and this is the theme of my new book on the future. Yeah.
Yeah. So let's go through some of those. Well, I guess we would call them existential threats. You're concerned about things like nuclear weapons, global climate change, as either species extinction or probably more likely just setting back civilization significantly enough that we're not going to make progress for a very long time.
Mm-hmm. Yes. Well, of course, the first threat was, as you say, nuclear, and we were lucky to get through the Cold War without a big disaster, especially if you listen to the pronouncements that came from McNamara and Kennedy afterwards. So we were lucky, and that threat is somewhat in abeyance, but it could recur. And that's based on 20th century technology, nuclear physics. But of course, in my book, I discuss two classes of threats. I discuss first the threats we are causing collectively through the fact that our numbers are growing, 7.7 billion now, and rising, and each of us is more empowered and more demanding of resources and energy, and affecting the climate and the environment more. That's one class of threats, the ones that we're imposing collectively.
Although you were skeptical of Paul Ehrlich's dramatic apocalyptic predictions, so you don't go that far.
Oh, no, I mean, the point is the population has doubled since he wrote his book, and the food production has more than doubled. So starvation is due to wars or maldistribution. So I think we can feed 9 billion people, but we do need to worry about the energy they use and the land use changes they cause, which will perhaps lead to mass extinctions and global warming and all those things. So I do worry about those, and that's why we do require to change the lifestyle, and that's why I favour clean energy of all kinds, including nuclear, and developing artificial meat and things of that kind.
Right.
If that happens, then we couldn't sustain 9 billion people. But on the other hand, I think we all would hope that the population doesn't continue rising after 2050. It's almost certain to rise to about 9 billion by 2050, barring some huge catastrophe before then. But what happens after that is more under our control. So I think we do need to worry about crossing tipping points there.
Right.
But I think in the short run, I worry more about the other class of threats, which are
Well,
those.
let's get past that because the key seems to be Africa.
Yes,
The general rule is that if you educate people, particularly women, and they have some economic power and access to birth control, and they're educated in this, then population numbers automatically come under control because women control family size, and so the numbers start to drop dramatically. The question is, will that happen in Africa like it has elsewhere?
yes. Well, I mean, I think we don't know. I mean, a colleague of mine, Parthas Gupta, has argued that there may be social pressures for large families even when they have the choice. And if that were to happen, then the population of Africa could double again between 2050 and 2100.
That would be bad.
And that would be the world
Are you talking
population.
about Catholicism?
Sorry?
Are you talking about Catholicism and their emphasis on large families?
Not particularly. I mean, that is relevant, as is the young marriage age in Muslim countries, etc. Those are relevant. And I think, I'm not too pessimistic about the rise continuing, but if it did, that would be very, very serious, especially serious for two other reasons, which I mentioned in my book. The first is that, of course, even if there's an economic gap which gets larger and larger between Africa and the more developed parts of the world, the one thing which they do have already in Africa is internet and smartphones. Right. So they now know, in a way they didn't 50 years ago, what they are missing.
Right.
And this is a recipe for disgruntlement and more, because they realize how unfair their lot is compared to the rest of the world. And there also is greater ease of migration. So I think mass migration will be inevitable unless we in the prosperous countries actually help Africa to develop economically. And we need help because the other thing that's changed is that because of robotics, which now take up manufacturing, African countries won't be able to raise their game by undercutting wage levels in the West, which is the way that Taiwan, Korea and Vietnam have raised their economic level. That route has been cut off now because robots take over that sort of manufacturing.
Right.
What's called reshoring of manufacturing in rich countries. And so Africa will not have the advantage which those East Asian countries have. So I think for that reason also, there's got to be some massive effort, a sort of super Marshall Plan, if you think back to
right.
what we considered after the war, to support African development. And that's in the interest of the rich countries as well as the Africans themselves.
I'm glad to hear you support nuclear because people don't seem to realize when you shut down a nuclear power plant, it's not replaced by solar and wind, it's replaced by coal plants.
Well, that's right. And I think we should support research and development into fourth generation nuclear because, of course, most of the designs being used now date back to 1960s.
Right.
The fourth generation ones are, traveling wave, pebble bed, and all these new designs ought to be tried. And also fusion. It's good that there are several private companies as well as the big international project trying to develop fusion. So I think we should scale up the level of R&D into all kinds of non-carbon energy to a level closer to that of defense research or health research. It's now far below that. Right. If you can scale it up, then we'll have a better choice. And also, this will be important for other countries like, say, India, where they don't have a proper electric grid. They have stoves burning wood and dung in people's homes. And as they develop, they're going to use coal-fired power stations, cheap coal in Australia, unless and until the clean energy is just as cheap. So what we've got to do is to accelerate the R&D into clean energy so it becomes as cheap as coal. And then, of course, the Indians can leapfrog directly to that, and other developed countries can as well. And that's, in my view, the only way we'll meet these IPCC targets of cutting global CO2 emissions.
Right. Without nuclear, though, the numbers don't work out in terms of like just renewables like solar and wind, geothermal to sustain, say, 9 billion people in 2050. I don't see how you can do it without nuclear.
It's very hard, but of course, to do that, we're certainly going to need better storage, better batteries. And another thing we're going to need is a direct current transcontinental grid to, in Europe, carry solar energy from the sunny south of Europe.
Right.
A place like Britain, where there's not much
Or
sunshine.
batteries, big batteries.
Right. Yeah. Well, if you can average over many time zones, for instance, that helps, because peak demand is at 7 o'clock in the evening
Right.
in most countries. And so if we can have a grid going, well, if you can have it across the US, that would help a bit. But if we can have one which is really linked to the Chinese Belt and Road Initiative, going all the way from Western Europe through to China, that would really help by averaging out the climatic variations and also the peaks in different time zones. So I wouldn't be completely pessimistic, but it's going to demand huge integrated projects like that to make it work. And, of course, advances in storage.
Right. Like Elon Musk's wall-size home batteries.
Yeah, that's right. Mm-hmm.
Then you can store whatever soaked up here in Southern California during the day.
That's right. So it's not hopeless, but it's difficult.
Yeah. Yeah, on the concept of Kardashev's type 1, 2, and 3 civilizations, last time I saw a calculation, it was like we're 0.72 or whatever, but we really have to get to a completely renewable energy and probably not dependent on nuclear, and that's probably going to take a couple centuries or maybe a century.
Well, I mean, it could be speeded up. I think the point, as I say, the level of research and development is very low compared to in other areas of defense research. If there was something with the urgency that happens in wartime, for instance, to
right. A
I'm
Manhattan
sure
Project, yes.
Yeah, they could do it in 20 years, I'm sure.
Yeah. By the way, you mentioned the Impossible Burgers, I think, in your book.
Yes.
Yeah, I had one of those last month at a vegetarian type conference. It was pretty good. They're trying to get them placed in the meat section, the burger patties, the meat section of supermarkets, because people still have this conceptual idea that it's not a real burger or it's a vegan burger, and it's in a different cognitive category than meat.
Yes, but it's still sort of low tech, isn't it? These beetroot juice instead of blood and all that. But the high tech version is actually to start with one cell,
right?
Animal,
Stem cells, right?
Which really is chemically and the same as meat, but doesn't come from a whole animal. And that's the kind of thing that I think is now being developed. But those are the burgers that still cost $100,000, I think.
That's right. Yeah.
So if their cost comes down,
right.
That's a real thing. And I think that's a hugely beneficial technology.
You don't spend a lot of time on factory farming in your book, but it sounds like it's something you're concerned about, that we have to get off of factory farming, animal farming.
Well, I think on ethical grounds we do. I mean, I think we can feed the world by intensive agriculture of all kinds. I mean, using GM crops, etc. And there's what's called vertical farming, where you sort of have whole layers of things growing, at least vegetables and salads. You can do it that way. But I think the present factory farming, which really treats animals like vegetables, will be perceived in future as being one of the sort of evils of this age. So, and I think people become more sensitive. And I was asked recently, what predictions did I make about 2050 in terms of ethics? And I said more vegetarians and more euthanasia.
What was the second one?
Euthanasia.
Oh, yeah, euthanasia. Yeah. I agree. Yeah, I think in terms of moral progress going forward, it would have to be animal rights, expansion of the moral sphere to encompass all sentient beings, and then possibly AI rights. Which is, I saw a story 2 days ago was the 50th anniversary of the Universal Human Rights Declaration of Human Rights, and then so somebody was talking about we have to consider putting robots in there at some point.
Well, this is a big issue, isn't it? Whether they will be conscious or be zombies, because in principle it could be that even if they have human capabilities, they don't have an inner life, as it were, or consciousness. We don't know.
How would we know?
No, but that makes a big difference to how we treat them, because if they are conscious, then of course we ought to care about whether they develop their potentialities, just like we care about other people and even animals, and we should be concerned if the robot is underemployed or bored. But on the other hand, if they are really zombies, then it's not quite the same. And incidentally, this does affect the way people react to the sort of long-range future, which I spell out, where, in a sense, the intelligences may be downloaded to electronic entities.
Right.
Because if they are sort of, in a sense, more aware with deeper thoughts than us, that seems something we should welcome. But if, on the other hand, they're zombies and there's no one to actually appreciate the beauty of nature, etc., then it's something we should deplore. So I think this question, it's not just a semantic question like do submarines swim. It's a question that has real impact on how we react to these particular far future scenarios.
I once met David Ferrucci, the lead IBM scientist that programmed Watson that won Jeopardy.
Oh, yes. Yeah.
And I asked him, does Watson know that he won Jeopardy? I mean, was he like really excited? I won Jeopardy.
Yes, obviously not. No.
Although you could program in there that he screams, "Hooray, I won," or acts excited. But that would still not give us his internal state. Does he feel excited? Does he? And if he lost, does he suffer? And is he sad that he lost?
Yes, and this affects, incidentally, the question of whether it's ever realistic to have cyborg add-ons like a memory stick to improve my memories. I'd love to have.
Right.
Or to load our memories into something electronic. Would it still be us? Or is our individuality so linked to our body and our particular sense organs that it wouldn't be us? And of course, we have to ask Mr. Ray, what's his name, Kurzweil.
Kurzweil, yes. Well, that's where the singularity is near, yes. I want to ask you about that. But first, the question about AI suffering and self-awareness, it's really just the extension of the problem of other minds. I mean, how do I know you are not a zombie? And you could ask the same question. And we don't, other than, so here's my answer, quick and dirty answer to the question is that the Copernican principle says we're not special. And if I apply it to me, I'm not special. There's no reason I should think I'm the only one on Earth that has a sentient brain and everybody else is a zombie. And you would have to make the same application. So at some point, wouldn't we intuit, I guess, through some subjective set of criteria that Data on Star Trek is a person or, with the equivalent of that, just because they have all the signs of it?
Perhaps we should, but I mean, some people would say that there's something special about the way the brain is networked and the particular kind of wet hardware we have in our skulls that may be different. And that's related to the question of whether machine intelligence will achieve human levels by simulating the way the brain operates. Or is that as absurd as trying to make flying machines by imitating birds?
Right.
Just don't know. But I think some people might say there's something rather special about the way the brain and entities made of human flesh operate. I would bet against it, but I think it's not quite such a clear-cut argument.
Right. Give us your thoughts on that as a potential threat to the future of humanity. That is AI. That's a popular meme going around now that this is a serious threat.
Well, I mean, I think in the short run, it's clearly going to be something which is transformative of society by taking over certain kind of jobs. We're familiar with that. And, of course, the jobs it will take over are not just manufacturing jobs, but, of course, some professional jobs like legal work, radiographers, maybe surgery, maybe computer coding, all those will be taken over. But some jobs, some blue-collar jobs like plumbing and gardening will be very hard to automate because they're very non-routine. They involve interacting with the external world. So I think that will happen. And I say in my book that in response to that, we've got to ensure that the owners of the robots are heavily taxed so as to set up huge numbers of new respected jobs for things where we want humans still, like looking after old people, teaching assistants, maybe gardeners and custodians and people like that. We need far more jobs. I mean, certainly in Britain and in America, if you're rich, you can have a human carer when you're old. Otherwise, you can't get that. We ought to provide that sort of thing for everyone. And incidentally, that's a far more valuable job than working in a call center or warehouse, which are the kind of jobs will be replaced. So I think this is something which I think will happen in China. It'll happen in Scandinavia, but it may not happen in the US because you don't like paying high taxes. So I think you may be left behind in this transformation. But I think that's what got to happen to provide a good life and satisfaction and dignity for people in this new world. But I think another issue which is near term in AI is that it's clear that AI can do a better job than humans, not only in playing games like chess, but also in managing large complex networks, electricity grids, traffic flows, etc. But there is the issue of whether they should make decisions that affect us. I mean, I think that this is already coming up. There's been these algorithms to decide whether you should be let out of prison on parole, all that, and whether you should get credit from the bank, and whether you need an operation or something. And I think the dilemma is that even if there's evidence that the computer makes better judgment than the average human, people still somehow feel that they're entitled to an explanation and entitled to question that decision.
Right.
And if the machine can't actually give reasons, then I think we're rightly going to be uneasy, because there may be some sort of mysterious bug in it. And so until the computer gives reasons for why it's keeping you in prison or something like that, I think we'll be quite rightly unhappy. So these are near-term concerns. But the longer-term, more futuristic concerns, of course, are the machines taking over completely.
Right. You probably know about that research on judges giving parole or not. Afternoons versus mornings, whether they've eaten or not. Of course, they're not aware that they have this bias, but it's apparently there.
No, clearly there are lots of human biases, but also there's also evidence that if the machines learn from data about what humans have decided, then of course they take over all the biases that we humans have.
Right.
So it's very hard to get rid of those.
Right. Give us your thoughts on universal basic income as a solution to AI displacing people out of work?
Well, I mean, I don't think there should be a handout for people who are able to work. But as I said, I think there should be publicly funded jobs in sufficient numbers to employ everyone as carers for old people and for young people, and doing other things which are of social benefit. So I think by redistributing the wealth earned by the robots, one could provide enough numbers for everyone. And as I said, these jobs are more dignified and satisfying than much blue-collar work now is. I think so. I think that's the way to go. And this will require probably high taxes.
Yeah. Yeah, the redistribution problem in terms of what people have to do to get the money. I mean, with UBI here in America, they're talking about like $15,000 a year, or maybe $1,000 a month, something like that. The problem is people that are drug addicted or homeless or whatever, they're just going to spend $1,000 in the first day of the month, and then what?
Yeah. Mm-hmm.
Then you still have the problem.
You've got real social problems in the US with the opioid crisis and all that, which are very serious. Yeah.
Right.
But of course, what's gone wrong, and it's true not just in America, is that blue-collar workers haven't got any better in real terms in 20 or 30 years. They've got one new thing which improves their lives, and that's access to IT and the internet and all that.
Right, Pornhub.
Yeah. But I mean, that's an example of something which we'd be prepared to pay far more for than we have to. For instance, I'd be prepared to pay a lot more for internet access than I have to pay to run my car.
Right.
But I get the internet access essentially free. So that means it's a genuine benefit, which doesn't appear in GNP. So if you put that in, then perhaps there has been some benefit even for the blue-collar workers. But against that, they've lost their dignity and status.
Right.
And that's why these divisions are really worrying in Western society.
So your main concern about AI going forward is the unemployment issue and more practical social problems, rather than like Nick Bostrom's paperclip maximizer. It's going to turn the entire planet into paperclips or whatever.
I think there is this issue about whether one can teach them common sense, as it were, teach them some ethics and and not to let their goal override everything else. A simple example is, if you have a robot in your kitchen and you run out of meat, it's got to know not to put that in the oven.
Turn you into hamburgers.
Yeah.
Yeah,
we
here's
grow up.
here's how
Learning
I think of it.
the computer won't know them.
Yeah, I drive a Tesla. So if I program in, take me to LAX from my
Yes,
home,
yes,
it's going to navigate, the shortest possible route. But
yes.
it's not going to take me up on sidewalks and mow down pedestrians because that's
No,
the shorter way to go.
yes,
And
no,
if it
no.
did, it would do that once before Elon was sued by the federal government and
Yeah,
regulated. And, so these kinds of problems, I think, would be just
yes.
bumps along the road that you would have to solve with
Yeah,
more.
yeah. Well, let's hope they can be solved because there'll be huge benefits. Although I think it'll be quite a long time before we have self-driving cars on ordinary roads mixed up with ordinary traffic. I think that'll be a long time.
Yeah, I like the self-driving mode when I'm on the freeway. I would not
Yeah,
trust it yet, just navigating around small streets, particularly with everybody else. If they were also
that's
self-driving,
right. That's right.
it's still not clear to me if this idea that 100,000 of us are going down the 405 freeway at 90 miles an hour, 6 inches off of each other's bumper. This is
Mm.
supposedly the solution to LA traffic. Well, what if I
Yeah,
want to get off at this next off ramp? How is that coordinated?
well, I think it's very hard. And of course, the other problem is that another negative trend is we are spending more and more of our time dealing with security. It
Right,
wouldn't be, let's say, if we all trusted each other. We already have vexatious security at airports and passwords and all that. And of course, cyber attacks are getting more serious. And of course, driverless cars will be subject to those. And already I was told that you have cruise control and all that on cars, and someone can make every Mercedes in the country veer left off the road by
right,
some
right.
software.
I have been told this about my
Yeah.
Tesla, and I said, "How could they do that?"
Yeah,
And
yeah.
this is because you're online. I said, "I'm not online." It's like, yeah, of course your
One
car
of
is online.
the main themes of my book actually is how we can cope with the fact that these new technologies, cyber, AI, and of course biotech, do empower small groups of people, or even individuals, to, by error or by design, have consequences that could cascade very widely indeed, even globally. And I think this is what I worry about most in the next 10 or 20 years, that this will lead to a growing tension between privacy,
Right.
liberty, and security. And how we're going to cope with this is not clear. And everyone says, well, in biotech, we regulate it all. And indeed, we're quite right to try and regulate it on ethical and prudential grounds.
Yeah.
But forcing those regulations is going to be as hopeless as enforcing the drug laws globally or the tax laws globally.
Right.
You can't do either of those things. And so
Right.
my worry is that anything that can be done in biotech will be done somewhere by someone,
Right.
whatever the regulations say. And that is sort of scary. And I just don't see a way out of that.
There's much talk now, just in the last couple of months, about the government regulating the big tech companies, Google and Facebook and Twitter and so on. What are your thoughts on them self-regulating before the government steps in to regulate?
Well, I mean, I think it's clear that there needs to be some regulation because many of the uses which they're put to now are clearly damaging, and they give advantage to extremists because however crazy you are, you can find a few people around the world who share your particular kind of craziness. And this, of course, we know is going to be, and David Brin was one of the first people who
Right.
did this about 20 years ago.
The Transparent Society, yeah.
Yeah, that's right. And I think we're going to need the transparent society in order to avoid these risks. And of course, the Chinese are heading towards this faster than we are because 80% of financial transactions by individuals are now done electronically. So they have that. And incidentally, the Chinese, if they wished, could have a planned economy of a kind that Marx could never dream of. The reason
Right.
the economy didn't work in the Soviet Union was they had no information. Whereas I think now they have the amount of information and the ability to process it so that they could make a planned economy work if they wished. It's a big change. But of course, that leads back to the question of how happy are we that a few big companies, maybe 3 in the US and 3 in China, are going to dominate this entire technology. That's
Right.
a worry.
Right. I keep wondering, why aren't there 6 YouTube companies that compete, such that when YouTube apparently discriminates against conservative voices, this is the claim, there isn't a conservative YouTube or whatever to compete with them.
But they're a natural monopoly, aren't they, in a way?
It's hard to get a toehold. Even a Silicon Valley billionaire starting a new video channel may not be able to compete simply because of the market momentum that YouTube has. Yeah. Or Twitter, whatever. How am I going to transfer to some other platform and take my however many followers I have, 160,000 or something, and I start off with one? I don't want to do it. I want to stick with Twitter, and that's how everybody feels with Facebook. Bringing back MySpace, it's just not going to work.
That's right. Mm-hmm.
Yeah. So you must be. Are you following this?
That's all. Yeah.
Are you following the story out of China, where they're gonna put out, I don't know, a couple 100 million cameras and track every single person by face, including everything they say, their interactions, and then award social points.
Yes,
so
that's right.
If you're a good citizen, you're more likely to get a discount at the.
Yes.
This is
but that's
deeply
the only
disturbing.
way to run the world.
Say that again.
That may be the only way to run the world, because I do worry about the vulnerability which we have simply because the empowerment of a few individuals cause disruption is so great, and also because our society is very fragile. I mean, it's very easy to cause disruption, and if you think of pandemics, whether natural or artificially induced, I mentioned my book that's in the Middle Ages, half the population of some towns was destroyed, the West went on fatalistically. Whereas now, I think if there was some sort of disruption which affected, say, even 1% population, that would overwhelm all hospitals.
Oh, right.
And if that happened, everyone would clamour for treatment, and there'd be a breakdown in order completely because expectations are very high.
Right.
And I think, so I think keeping society together is going to be very, very hard. And also, of course, the effect of cyber attacks. And I quoted in my book a 2012 report from your Department of Defense, which talks about the effect of a cyber attack state level, which holds down the electricity grid on the East Coast of the US. And it says, I quote, "This would demand a nuclear response."
Wow, right.
And I heard General Petraeus say this same thing more recently, and of course, understandably so, because if you shut down the electricity grid in New York, then you get complete chaos within 2 or 3 days.
Yeah,
society couldn't survive.
Right, a nuclear response. Oh boy.
Yeah.
So when you wrote Our Final Hour, I think that was during the Obama administration, and then this one you wrote. It seems like you wrote it right around the time Trump was elected, or shortly after that. So you must have something of a change of.
Well, I mean, Final Hour was actually much older. It was 2003.
Oh, okay.
So it was much older, and I think it was quite prescient in sort of raising the concern about the empowerment of individuals, because we didn't have the internet really then.
Right.
So I think I followed that up. But no, I mean, well, of course, I'm writing from England, not from America anyway, so I don't think I mentioned Trump at all.
No, you didn't. But
although the book was written, it went to press about 9 months ago.
Yeah, but just the shift generally from what we had, say, in the 2000s to this more populist, authoritarian nationalism. I mean, for somebody that looks to the future, this, as I do, is a disturbing trend backwards a little bit.
It is indeed, and that, of course, we haven't escaped it in Europe. We've escaped someone like Trump, fortunately. We haven't escaped this issue. And I think it's something I alluded to earlier, which is that the traditional blue-collar workers, as you call them, have lost status and lost value, and they feel they're overlooked, and inequalities have grown. And I really think that it's not just in comparing the rich country with Africa that we need to worry about growing inequalities. We have to worry about it within each country, because what is happening is that the people who supported Trump, I mean, they're people who are conservative in many ways, but radical in other ways, and I think they feel embittered and overlooked. And we have a similar issue in our country, in Britain.
Right. So let's look forward, assuming we get through to the 21st end of the 21st century here and beyond. You speculate toward the end of your book about space exploration, not just exploration, but colonizing other planets, and how realistic is it that we can get to other stars?
Well, I think other stars is really a post-human enterprise because of the time scale, but I think manned space adventure is realistic. And one perhaps rather distinctive point I make in my book is that if I was an American, I wouldn't support NASA's manned program at all. The reason for that is that it's very expensive,
right,
because it's forced to be so risk averse. I mean, you had the shuttle which launched 135 times, I think, and there were 2 failures,
right,
which were spectacular, and each caused national trauma and delay of the program for 3 years, etc. That's because it was presented as safe. They sent up a school teacher and all that, and and it was thought the 2% risk was too great. So I think space is going to be inherently very expensive if it's going to be done in such a risk-averse way. Moreover, the practical need for people to go into space, which of course existed in the past, is now eliminated by robots, because we don't need them. Robotic geologists to Mars. We can have robots fabricating big structures in space and all that. So we don't need people. So people will only go into space if they're choosing to go as a sort of adventure.
Right.
Mountaineers and round the world balloonists and all that. And they're prepared to accept high risks. And that's why I'm very positive about SpaceX and Blue Origin, the companies run by Elon Musk and Jeff Bezos, because they are pushing the technology hard, and it's wonderful what they've done in bringing down the cost of launches, but also they're prepared to take higher risks.
Right.
And what they should not do is call it space tourism.
Right.
They should call it space adventure, and take the kind of people who are prepared to accept a 10% risk of not coming back. And I think if this happens, this is something we should all cheer on, and it'll be private money, and it'll be great. And I think there will be people living on Mars by the end of the century. And of course, Elon Musk himself says he wants to die on Mars, but not on it, and he might make it.
Right. Well, that may happen well before the end of the century.
No, that's right.
Because there are people that have said they will be willing to take a one-way trip to Mars. They don't want to come back.
That's right. And I think they will. And I think we shouldn't think of it as something that has to be a national goal. It could be something which is funded by a corporation or wealthy individuals, and using their own money and their own taking the risks, and that's fine. But I think it's not just that we can enjoy them, just as we enjoy watching these hang gliders and all these people doing dangerous things. It is important, because I think it's those crazy guys on Mars who are going to really spearhead this transition to post-humans, because here on Earth, I hope we will succeed in regulating genetic enhancement and cyborg techniques and all that. And of course, we're pretty well adapted to living on Earth after Darwinian selection. But these guys on Mars, they're away from all the regulators. Moreover, they're very ill-adapted to living out there. And so they'll have the opportunity and the motive to use all the techniques of genetic modification and cyber technology to adapt. And they may become a different kind of organic being. They may become inorganic beings. So I think it's the people out on Mars who will be cosmically important, because they will sort of lead the transition from humans to post-humans.
And do you like that idea that they're an insurance policy in case we do nuke ourselves? Or
I suppose they are. I mean, they may not be the kind of people who want to represent human beings. Because there'll be a different species eventually.
There'd be a founding population of high-risk takers.
Right, yes. But I think one thing that astronomers are more aware of than most people is that the future is even longer than the past. I mean, most educated people, except those in Kentucky maybe, are aware of the outcome of 4 billion years of evolution. But I think many of them still somehow feel that we humans are the top of the tree and we're the end of it all.
Right.
Whereas no astronomer can believe that, because we know the sun is less than halfway through its life, and the universe will go on forever, possibly. And to quote Woody Allen, eternity is very long, especially towards the end.
That's right.
So we may not be even the halfway stage
Right.
in the complexity. And so post-human evolution has a long way to go. And this century may be important, not only because it's the first when we are threatening our species, but the first when we can somehow trigger the transition from organic entities to inorganic post-humans.
Simply because the material that it's made out of will last longer and won't break down as easily as the protein meat of our brains.
Yeah, and they could be immortal, and of course that's why interstellar travel is not crazy, because if you're immortal, then you don't mind spending 1,000,000 years on the way.
Right. Right. Timescales change.
Yeah.
So colonizing certainly Mars and maybe some of the planets around Jupiter or Saturn seems conceivable. But to get to the other stars,
they're not comfortable. I think the point is, if we look to the post-human era, then there will be these Earth-like planets around other stars,
right,
which you can't reach in a human lifetime. But they could be sort of habitable. But of course, the other point is that post-human entities, if they're electronic, they may not want to be on a planet anyway.
Right. That's right. You don't have to be on a planet.
Yeah.
I think it was Sagan that did these calculations where if you accelerated a spacecraft at 1G,
Yes.
so it's going that direction and people are living on the floor, essentially,
Yes.
they have 1G gravity, you can get to like 99% the speed of light within a few years or something
Yes.
like that. So you could get to other stars within...
Well, you can then cross the universe in your lifetime if you can
Right,
do that.
right.
Yeah. Mm-hmm.
Of course, you got to slow down if you're going to stop somewhere.
Yeah. And you need a big push to get her to keep that acceleration going, of course. Yeah.
Right. Yes. So that breakthrough project is still going on both. Weren't they sending some small spacecraft to
Well, yes.
to the nearest star?
Involved in is what's called Breakthrough Listen, which is the search for SETI, but there's a separate effort called Starshot, which is
Right.
studying a technology to have a huge laser on the ground, which can use a powerful beam and can accelerate a very small.
Right. Like a little CubeSat.
Well, yes, I think this would be just a sheet weighing 1 gram, even smaller than that, with electronics in it, like in a smartphone.
Right.
And the idea is this could get up to 20% of the speed of light and get to the nearest star in 20 years.
Right.
So this is the idea.
Is that going to happen?
Well, I mean, I think the two issues. One is the technical challenges about keeping the beam on course, and of course sending back any information when you get there. But I think the other point is that it would need a huge laser, which provides for 2 minutes a power of about 30 gigawatts, which is about 15 big power stations.
Oh.
So it's big. It's a very big project, and I think I should admit I'm slightly skeptical about this, because even if it worked, then we'd be thinking about something which would be which would operate, say, 40 years from now and send back data in 60 years. But I think on that time scale, I can imagine we could have robotic fabricators building huge telescopes, gossamer thin ones in space, etc. And if you gave someone $10 billion, which is the minimum cost this laser would take up, to build something to study exoplanets, I think most people prefer to spend it on some huge telescope in space, which would study lots of them. And one real goal, which I think would be nice when I mentioned in my book, is that by the year 2068, to have an image we can put on our wall which resolves Earth-like planets around another star. I say 2068 because that's a century after the famous Earthrise image,
Right.
which was taken by the Apollo astronauts orbiting the moon of the Earth. And so a century from now, we might have an equally iconic image. And I think that would come from some huge telescope in space.
Right.
Although, of course, to the R&D that's involved in understanding these lasers is interesting, because even if they don't really work for interstellar travel, they may be a quick way to get to the outer planets. And incidentally, going back to the origin of life and where life might exist, then in our solar system, one of the most likely places now is thought to be Enceladus, which is a moon for Saturn, which has ice and an ocean underneath. And it might be feasible to send some little probe there, powered by a laser. And of course, even finding the simplest life somewhere as our solar system is important, because if you can show that life originated twice independently,
right, second Genesis,
solar system, it's common, and it must be in a billion places in our galaxy. So it would be a big deal to find any life on Enceladus.
Given the number of things that have to happen between, say, bacterial grade life to big brain, space exploring species, telecommunication species, something detectable, you could get all the way to Neanderthals, who dominated Europe for several 100,000 years without much progress in their toolkits, and never get to where we are now. And that would be highly improbable.
No, indeed, that's right. So that's why even if simple life is common, it doesn't at all mean that intelligent life or at human level is common. It could be rare for just the reason you mentioned. And of course, many evolutionary biologists who are concerned with the Earth's evolution debate this. They say if the asteroid didn't wipe out the dinosaurs,
right,
what would happen? Would intelligence emerge some other way or not? So many people feel, and Stephen Jay Gould famously thought this, that if you were to run evolution, you get some quite different answers. So we got no evidence for how common intelligent life is, even if we understand how common the origin of life is.
I mean, given that somebody has to be first in the universe, maybe we're first.
Well, indeed, and of course, if that's the case, then of course, what happens to us this century, which
super critical,
it's important not just to us, but it's a cosmic importance. If indeed what we do this century can decide whether these potentialities I've outlined are foreclosed, or whether we are the instigator of these grander futures.
It does seem like we're on a precipice here where things could go very bad or very good.
But the stakes are high, and that's the main point, that the stakes are high in that if something goes wrong, it'll cascade globally in a way past. And the more things that can go wrong, which is a downside of the fact that technology is immensely powerful and can do wonderful things.
I was reading Daniel Ellsberg's latest book called The Doomsday Machine.
Oh, yeah.
You know, and Ellsberg worked for the State Department. First, he worked for the Rand Corporation, then he worked for the State Department under Kennedy. And the kind of numbers that these people talked about, that, we would survive with only, 80 million dead or 100 million dead. It's like, yeah, we may survive, but this would be just catastrophic.
That's right. Yes. Well, it was the famous Herman Kahn, wasn't there?
Right.
Who was the model for Dr. Strangelove in the movie, who talked about mega deaths and how it's
right. I think it was George C. Scott's character that said, I'm not saying we wouldn't get our hair mussed, but 20, 30 million tops. No problem.
But that risk is only in abeyance, because we could have a standoff between new superpowers, which is handled less luckily or less well than the Cold War was.
Right.
But I think we need to worry now just as much about bio and cyber threats.
Are you cautiously optimistic, or are you neutral, or what do you call yourself?
Well, I like to say I'm a technical optimist, but a political pessimist, in that
right.
We've already got the technology that could provide a decent life for everyone in the world, and it's the politics which is the impediment.
Yeah.
And I think actually ethically we are not advancing, because the gap between the way things actually are and the way they could be is actually widening, because in medieval times, as Steven Pinker emphasizes, things were pretty miserable for everyone. But it's not what they could have done to improve them. Whereas now we know there's a big gap, and a huge amount could be done, and the wealth of the 1,000 richest people on the planet could make a big difference to the bottom billion on the planet.
Yeah, you have that line in your book. How do you propose that a tax redistribution?
Yeah. I mean, well, some people, of course, like Bill Gates, are themselves doing this.
Yes,
and I think this is great. But it's obvious that more could be done, and it's not just. And although one thinks in terms of the very rich people, I think massive redistribution to reduce inequalities could be hugely beneficial for those who are now disadvantaged. And as I say, it's in our interests to ensure that the gap with Africa and the Middle East doesn't get wider, because otherwise that's a sure recipe for disruption if they know what they're missing and have ability.
It seems to me like, say, on the nuclear problem, it's more of a political or game theory problem than it is a technological problem. Even if we got to nuclear zero, you can always bring it back out of the genie's bottle. So it's really just setting up a social system where people don't want to do it, just like chemical weapons. Or there's a taboo against the use of chemical weapons.
Yeah, that's right. But of course, the nuclear is easy in the sense that it needs large special purpose facilities to build a nuclear weapon, and therefore verification is not impossible, and also it's made by states, and some individual small group hasn't yet created a nuclear weapon. They might steal one or something like that.
Right.
It's large special purpose facilities which are easier to monitor than what you need for biotech, which is access to dual purpose laboratories which exist in universities and many industries, and using techniques which are widely available. So, and of course, cyber already is just the same, because we know that lots of individuals can cause pretty catastrophic damages there. And so that's why I think the biggest concern, which could lead to a social breakdown, in my view, is not nuclear, but cyber and bio.
Yeah. So game theorists have what they call the other guy problem. I would give up my nukes, but the other guy is the problem, and I don't trust him. Again, it comes down to trust and open communications and transparency, these sorts of things that are social, political issues.
Mm-hmm. Mm. No, that's right. And I think it would be an interesting exercise to ask how much of our economy is simply there because we don't trust each other.
Right.
I mean, security guards.
Oh, it's endless now at airport. I can't stand traveling anymore.
It's becoming more vexatious and tiresome for all of us, and also is a drain on the economy, really.
How far does your techno-optimism go? As far as Ray Kurzweil and the singularities coming by 2040?
Well, I don't think it'll come that far, but in fact, I'm amused by one thing that Ray Kurzweil has done, and that's that he has arranged that when he dies, he wants to be frozen, his blood replaced by liquid nitrogen and all that, to be resurrected in some world when you can do these things, when he can be downloaded to a machine. And
that's the idea, yeah.
So he's doing this, and of course there is this company called Alcor, which does this. In fact, I mentioned in my book that I have 3 colleagues, academics, who have signed up.
They have the bracelet on?
Yes, but they have something around their necks, and 2 of them have signed up for the full whack. One for the cut price, just having his head frozen. But these 3 people are all academics.
So if they keel over in your presence, you have to go get some dry ice and start the cooling off process?
Pretty quickly in the first half hour, etc. But I'm glad they're all at Oxford and not in my university. And I tell them I want to end my days in an English churchyard, not an American refrigerator.
Right. Yes. Well,
actually, just to pursue that a bit, and this is relevant to Kurzweil, if supposing that it was possible to revive them, which is most unlikely anyway, and suppose that Alcor, the company, didn't go bust for the next 200 years, then these people are being rather selfish, because they'd be revived into a world when they would be perceived as sort of strange aliens, etc., refugees from the past. And, we feel an obligation to help someone who's a genuine refugee, or an Amazonian tribesman whose habitat's been destroyed, etc. But these people are voluntarily putting a burden on future generations, and welcomed or not, or just put in a zoo, I don't know.
The other problem, well, it's mostly technological with cryonics, but Ray's idea of mind uploading. So this is a chapter in my latest book, Heavens on Earth. I see it as more of a philosophical problem, that copying your connectome and uploading the digital file into the cloud, that's not you. It's a copy of you.
Absolutely. I mean, I think it's I think we are so linked to our bodies and the way we sense the world, etc., which the standard would not do. And also, the other question: suppose they make 10 copies
Right, which one is you? Each of them thinks that it's you, but and let's say they did this with you, Martin, and while you're still alive, we slide you into a sophisticated fMRI brain scanner, copy your connectome, upload it to the cloud, turn it on. It may even think it's you, but you're still standing there going, no, dude,
right.
I'm the real Martin Rees. You're just a copy. And he goes, well, no, I'm the real one.
Yeah. No, these are, philosophers have studied these for a long time.
Problem of identity. There has to be a continuity.
You have to think about these things, yeah.
You have to be a continuity from one moment to the next. And you can break the continuity through sleep, say, for example. But if we copy you, then the continuity is broken, and the point of view self doesn't go with the file.
Yeah. Mm-hmm.
So I don't see that as a solution to immortality.
No, I don't think so. No.
Yeah.
But I think in the shorter run, of course, life extension is being pursued by serious people. And the question is, how much change will they make in extending our healthy lives?
Well, I'm all in favor of, like, Calico. Google has a company called Calico, and Jeff Bezos has put money in his company. They want to treat aging as an engineering problem.
As a disease.
As a disease. Okay, fine. Look, because they say, Shermer, don't you want to live to be 500? My answer is, look, just get me to 90 without, like, prostate cancer and Alzheimer's and senility. And so if they can solve specific problems along the way.
I think that's true. But if it becomes feasible in a big way to double people's lifespan, obviously you have to ask what will family structure be like,
marriage,
all that. Right. But also it'll be a new and fundamental kind of inequality if it's only accessible to the rich.
Oh, well, yeah, the idea is that it would just become super cheap, like going to the grocery store or whatever. Everybody can afford it.
If it does, that's all right, because in fact, in the last 100 years, medicine has been an equalizer. It extended lifespan in Africa more than it has here. And so that's good. But it could be that this high-tech medicine is going to open up a new gap, especially if you can enhance people's intelligence and all that. Which
right.
It's likely, but maybe possible.
Exciting times we live in.
That's right, yes.
This is even better than the 60s when you were going through the Big Bang versus steady state theory. This is hugely consequential. So what's the next book? What are you working on now?
Well, I've got a book that I've been working on slowly for quite a long time, which is really on the limit of science.
Okay, yes, you mentioned that at the end of On the Future.
I suppose my main message is that cosmology and microphysics are not the hardest science. I think, as we said earlier, we probably make progress in those, maybe with the aid of some AI. But of course, the extent to which we'll ever understand the complexities of our everyday world is
the social and economic world.
Yes, and how our brains work. And of course, people are sometimes surprised when I tell them that these two neutron stars crashed together 1 billion light years away, two black holes. And I can tell you about that, and they ought to believe me. I think we do have good evidence for things like that. On the other hand, you're foolish to take seriously anyone who gives you advice on diet or childcare.
Right.
Because things we all care about, and they're important to us all. But as we know very well, they are not well understood, and fashions change from year to year, as we know, because we don't understand them. And that's simply because those are far more difficult problems.
It is stunning
that couples together is something we can actually calculate, whereas what happens in our brains and bodies we can't. Right. And so the three frontiers of science, the very big and the very small, which physicists work on, and the very complicated, which are things like us. 99% of scientists work on the frontier of the very complicated.
Right.
Particle physicists, they're not astronomers, and that's appropriate because it's the intermediate scale, the everyday scale, which is most complicated and matters most.
Yes, right. It's complex systems like the economy. I've had nutritionists on this show, and I can't get a straight answer to, like, in the morning, should I have a bowl of oatmeal or should I have 2 eggs and a strip of bacon?
That's right. That's right. Yes.
How can that be?
Well, I suppose it's partly that they can't do control experiments.
That's right. Yeah, it's very, very hard.
But it is just very difficult, isn't it? We don't understand all these
Well, most of these studies are done, when you look into them, actually on self-report data. They ask people, what did you eat? as if
Yeah, yeah.
people keep track accurate measurements, or they misremember, and
Right, right.
issues like that. Yeah.
Yeah, yeah. Hmm. Hmm.
But something like the economy, again, we don't. What's the right tax rate? Well, it depends what the goal is, and there's not simple answers to these things.
Yes, but I think the economy perhaps can be simulated better by computers, just like the climate can.
Right.
Where weather and climate, they're very complicated, but there is some hope of using computers to get a slightly better handle on them,
Yes.
and differ for economics.
So on this next book on the future of science, the limits of science,
Yes.
how do you respond to the argument that, well, all the big stuff has been found, natural selection and gravity and general relativity, it's just kind of fine tuning what we know?
Well, I mean, I think that assumes that the only important science is particle physics. It's true that particle physics has not been developed very fast in the last 25 years. In fact, the only real development actually is learning that neutrinos have a mass, which came not from accelerators but from underground experiments and astronomy. So it's true that the low-hanging fruit in that subject has been picked, and it's going to be slow.
Yeah.
But that's just one subject, and I think unless you're an extreme reductionist, then you would consider all the other sciences, material science, cell biology, all the way up to psychology and sociology, as being equally important, and they're just beginning. And I don't see why one should say that that's less important. I mean, to understand the details of evolution, to understand details of how animals behave, etc., to understand a fly's wing even.
Right.
That's a big challenge. And so I think the rate of advance is as high as ever. I mean, if I ask what's amazed me most about science in the last few years, is learning about the experiments done by O'Keefe and Moser on how rats find their way around.
Oh, right.
You've seen these pictures of rats moving in a sort of enclosed space, and particular neurons beep in particular places, and then match out a pattern. And just to learn that's so fascinating.
Yes.
And so I think to believe that we're near the end of science is very implausible indeed. I mean, I think always some sciences end up going slowly because it's very hard to do the experiments. And some, of course, get fully solved. I mean, not many people work on atomic physics because that's been understood. But, of course, the physics of complicated materials still isn't understood. And the biological world is understood in quite the same detail that something in physics is. So I would say that science is just beginning in most cases. And it's only some subsets of it which are perhaps going slowly now.
Problem of consciousness. How do you explain consciousness? I mean, it's stunning that we've come this far and really don't have an answer.
Well, that's fully understand. Maybe no brain can understand itself. We don't know.
Right.
But again, we should try. And there's a long way to go before we should give up on any of these problems.
Yeah, for sure. And then scale up from there to social, political, economic systems as science.
Yep.
Study them like scientists do, statistical sciences anyway, for large aggregates of people behaving in a certain way. We can make certain predictions.
The averages, yes. Mm-hmm. Jeffrey West, I don't know if you know his books.
The scale, yes, the scale stuff. I also had Charles Cockell on the show talking about his new book, on looking at different scales of things. And but as a sidebar, we got talking about colonizing Mars politically. What kind of political system are you going to set up on Mars? Because whoever controls the oxygen, the production of oxygen, you have the recipe for tyranny and a monopoly that could be really destructive.
Yes, but I think that depends on whether you think there'll ever be a large population there.
Well, say over 100 or 1,000 people.
I say it'll be just a small number of people, and then I'm afraid the Wild West laws will prevail.
Right.
But of course, some people talk about mass emigration. Of course, Elon Musk does, or the late Stephen Hawking also talked about this. I personally think that's a dangerous delusion.
Yeah.
Because, it's a doddle to deal with climate change compared to terraforming Mars.
People make this analogy of Europeans coming to the Americas centuries ago.
Yes.
Well, but we have food and water here and air.
Yeah, absolutely. Whereas this is worse than living at the South Pole. Not many people want to do that.
Right.
So I think it'll only be a place for adventurers.
For sure. And it would take, I don't know if anyone's done the calculations of how long it would take to terraform Mars to make it livable where you didn't have to be in a spacesuit all the time.
Right. Well, Zubin did the work on this.
That's right.
Yeah. Yes.
Centuries it would take, probably.
A century. Yeah.
Yeah. That's great. Well, Martin, we've been going almost an hour and a half, so I just want to thank you for taking the time here and part of your day.
Anyway, and I hope that this.
I love reading your books because you're one of the big thinkers and deep thinkers. It's really fun to take some particular area of science and then expand out and see how far you can go, which is why you're always a joy to read.
Covered lots of topics, and as in my book, covers lots of topics, all rather superficially, I'm afraid.
You've dealt with religion. We haven't talked about religion at all. I think you're an atheist, right?
Yeah.
Yeah, but you're not a let's say an anti-theist of the sort of the new atheist form where you attack religion.
I'm not a believer, but I think the cultural aspect of religion. I'd be sad to see die out. I mean, as I say in my book, I was brought up in England in a conventional way, and the architecture and the music of the church was something that I grew up with, and I think it's something people bring in comments. So I'm rather anti the so-called new atheists, which is right. There's Dawkins. Krauss et al. I mean, they're really small-time Bertrand Russells. They say nothing that wasn't said rather more clearly by Bertrand Russell 75 years ago. And I think they actually do more harm than good in two ways. The first way is that clearly we want to have a fight against fundamentalism.
Right.
But I think people like the Archbishop of Canterbury and the Pope are on our side in that. And so to rubbish them is to weaken the alliance against fundamentalism. So that's one argument. And the second argument is that if you were a teacher and you had 16 neos in your class and some were Muslims and told them they couldn't have their God and have Darwin,
right?
They'd stick with their God and be lost to sight.
That's right.
That, again, would be very damaging. So those are two arguments where I specifically feel that these people do more harm than good.
So these are strategic arguments along the lines that Sagan made when he said we have to work together on climate change and getting to nuclear zero, and we need the Christians and the Muslims and the Jews all together.
Well, we do, because whatever one thinks about their faiths, there's no gainsaying that they are concerned with the long term, they think globally, and they care about the world's poor. And those are three things which we need to absorb in any argument about climate change.
But for you, it's also somewhat personal in the sense that even though you're not a believer, the cathedrals, the music, and all that does have some emotional impact for a lot of people. We have to recognize.
I think it does, because I was brought up in a country, but I think if I was born in Iran, I'd probably go to the mosque in the same spirit. Right.
Yeah, there seems to be an imprinting stage in our youth where whatever we're exposed to has long-lasting effects in terms of the emotional salience of that, whatever it is you were raised as.
But I think the point is that religious dogma is part of some religions, not others. But I think the important thing is that religion is something that emphasizes what we have in common.
Right.
Of course, I know there are divisions between religions, but within a religion, it emphasizes what people have in common and rites of passage and all that. And if we lose religion, it's not clear we have an adequate substitute for it.
Well, so there is, a movement amongst humanists to replace religion with something like a secular religion, where you go to a Universalist Unitarian church and they sing hymns to Newton and they light candles and they have testimonials about how they lost their religion and they found science and, that sort of thing. I don't personally, I've gone to a few of these. I don't personally like them.
No, but also you lose a tradition. I think it's good to know you're doing something which was done by people 500 years ago.
Right.
Especially at a time when things are changing far faster than ever before. So it's something which embeds you in a long continuity. and we need that. We need that more now. In fact, to develop that, one of the things I say in my book is about the cathedral builders. Added bricks to cathedral would be finished for 100 years.
Right.
And that may seem paradoxical because they thought that the world might be destroyed in 1,000 years in some apocalypse. But the difference is that now we know that the world will be around for billions of years.
Right.
But we don't plan so far ahead. But the reason is that we think that things are changing so fast. We don't know what it will be like for our next generation. Whereas the medieval people, they may have thought it would be an apocalypse in 1,000 years, but they thought the lives of their children and their grandchildren would be the same as theirs.
Right.
So
that's true.
Yeah, the continuity. And of course, we don't have that, but that makes it, I think, more important to cherish the heritage we do have, the buildings from earlier generations, and music, etc. And the religions help to keep that alive.
You probably know about Stuart Brand's the clock of the long now, the long
yes,
now. Yeah.
No, I think that's a secular version. But I mentioned this at the end of my book as being a secular version of the cathedral.
Right.
We'll be ticking away, and we hope we'll be visited by
right.
years from now. I think that's a very nice idea.
Yeah, I like that. My wife is from Cologne, so every time we go back to visit her family, we go into the dome there, right downtown, and I have to say, even as an atheist, it's deeply moving. It's hard not to feel the power of, I don't know what you want to call it, spirituality or transcendence or awe or something like that.
Yes, and we feel something in common with the people who built that, just as we do with ancient literature.
Right.
But one other point I make in my book is that things may be different in the future, because supposing that there is genetic enhancement and modification, etc., then it may be that a few centuries from now, the intelligence will have no emotional resonance with us and our literature. In the sense, we have a resonance with, if you read Greek or Roman authors, we can resonate with the authors and the artists, because human nature has really changed fundamentally in the last 10 or even 50,000 years. So we're the same as them in many important respects. But we can't assume that
about future
100 years from now. And that'll be a real game changer, and it's a more fundamental kind of change than anything that's happened to human beings themselves in the last few millennia.
Right. Well, there's the last chapter of your next book. Well, thank you so much, Martin. I really appreciate it. It's really a great honor to talk to you. I think the last time I saw you was at TED. We were each giving our TED All-Star talks. Mine was on moral progress, and yours was on things we should be concerned about. So it was a nice juxtaposition.
Yeah, that's right.
TED is in a way kind of I see it as sort of a secular spiritual thing. I mean, people feel like, we are here to change the world and thinking long term and all that.
It's good. The trouble is I can't afford to go except if I'm a speaker.
I know. I'm the same way. I keep waiting for them to ask me to give another talk so I don't have to pay the $7,500.
And I thought actually we're not recording now, I guess, are we? But I thought that, I did admire, because I remember they obviously sort of have people who aren't experienced speakers at all,
right?
And they coach them. And I remember there were two people I remember. But one was the guy who'd lost a leg in the army and started to worked at MIT doing prosthetics.
Oh, right.
And they talked about that. And then they had a girl who'd lost a leg in the Boston Marathon.
Yes, I remember that.
Stage. That was very touching, I thought. And another case was they had the guy who was a policeman who looked after the Golden Gate Bridge and tried to talk people out of suicide.
Oh, right.
He was a policeman. He probably had never talked before, but he gave a wonderful talk about what he'd said to try and talk people out of committing suicide on the bridge.
Yeah.
So when they get people like that who aren't normally on a stage, and they obviously coach them quite carefully, I think it's very distinctive and worthwhile.
It is.
I mean, we're old troopers, so we do a lot of this, so it doesn't the same to us. Mm-hmm.
Well, but that's, the sort of endless content now available online. Not just free TED Talks. I mean, Netflix, they post documentaries pretty much every day, half of which I want to watch. And
well, yes, I mean, it's embarrassing how much is online. I mean, if you give academic seminars in universities now, they're often online, and
Right.
you can't repeat yourself too often now because
That's right. Yeah. We've already heard you.
I could go to America and give a talk, which I've given here, and assume no one has heard it, whereas you can't, they may have watched it. So
there's a new documentary that came out last week called "The Creeping Line," about the title comes from a quote from Eric Schmidt talking about Google and how they've engineered their programs to go right up to the creepy line before of understanding our behavior before it gets really creepy if they cross the line.
I see.
And I think the idea is they crossed that long ago. It's already pretty creepy what they know about us. There was talk yesterday about people that go missing. They can find them if they have their phone on because they know where you are. They know where you are all day, every day. They know what you're thinking about because you Google stuff. And it is a little creepy. We're getting close.
Incidentally, I was interviewed by Christiane Amanpour.
Oh, yes. Yeah.
Yes. She's rather good, I thought. And also it's a good hard talk, which is a British.
Oh, right.
British programs. I did that. But of course, one guy who's no longer available is Charlie Rose.
Yes, right.
Which falls into disrepute.
Yeah.
That's
right.
Several other people in the States.
Well, journalism is changing dramatically because of technology. And anyway, it's all a very exciting time.
Yeah.
So,